Learning from demonstration methods usually leverage close to optimal demonstrations to accelerate training. By contrast, when demonstrating a task, human teachers deviate from optimal demonstrations and pedagogically modify their behavior by giving demonstrations that best disambiguate the goal they want to demonstrate. Analogously, human learners excel at pragmatically inferring the intent of the teacher, facilitating communication between the two agents. In this paper, we implement pedagogy and pragmatism mechanisms by leveraging a Bayesian model of goal inference from demonstrations. We highlight the benefits of this model in multi-goal teacher-learner setups with two artificial agents. In the first phase, the naive teacher is pre-trained to master all goals while the pedagogical teacher is additionally pre-trained to better infer goals from its own trajectories and effectively modifies its policy to produce demonstrations with less ambiguous goals. In the second phase, the learner is trained using the teacher's demonstrations and goal-conditioned reinforcement learning. The literal learner infers goals from demonstrations and is rewarded for correct inferences while the pragmatic learner additionally trains itself to infer its own goals from its own trajectories and effectively modifying its policy to better infer goals from the teacher's demonstrations. We perform our experiments in a block stacking environment with two fetch robots, teacher and learner, equipped with robotic arms, based on MuJoCo. In the first phase, we train naive and pedagogical teacher. Let's see what is the difference between those two agents. Assume the teacher wants to demonstrate a goal state where the blue block is close to the red one. A naive teacher may move the blue block to the red one, but this would be ambiguous. Is the goal to put the blue block close to the green one or to the red one? By contrast, a pedagogical teacher would move the red block close to the blue one, hence away from the green one, resolving the ambiguity. The pedagogical teacher is introduced to avoid ambiguity in demonstrations. To compare pedagogical and naive demonstrations, we derive an ambiguity score, given two ambiguous goals that can be achieved simultaneously and a starting state. The ambiguous score is 1 if their associated demonstrations achieve the same goals. The demonstrations are thus ambiguous, and 0 otherwise. In this example we can see that the naive teacher performs the same demonstration for two different goals, hence providing ambiguous demonstrations. By contrast, the pedagogical teacher provides non-ambiguous demonstrations, making it easier for a learner to predict which goal it is trying to demonstrate. In the second phase, the learner is trained to master all goals using the teacher's demonstrations and self-exploration. We experiment with a different number of demonstration per goal and observe that the combination of pedagogical teacher and pragmatic learner always performs best. This especially shows in the few demonstrations regime, where the pedagogical teacher plus pragmatic learner combination does master all goals while the naive teacher plus literal learner combination does not. Here, we show the behavior for achieving a stack of 3.